3-month required research block, and I went to Uganda to do G6PD deficiency research, and I worked at Kampala, which is the main city, and I just really enjoyed the whole process and wanted a longer, extensive research. So I applied to the Doris Duke. And so this year I'm going to Tororo, which is 3 hours away in the Garoa city nearby. So this is the team I'm working with. Dr. Rosenthal, he's my PI, and then as you can see there's a bunch of people both in country, so in Africa and out. There's some people in the genomic lab. So my research question is, what is the cause of non-malarial febrile illnesses in children in Tororo, Uganda? So the place I'm going to is right on the border of Kenya, right here. So just a little bit of background. Febrile illnesses are extremely common in African children, with estimates of 870 million episodes per year. And just like developed countries, or the developed world, many of the causes of febrile illnesses are similar, just viral pathogens that spontaneously resolve. But in Africa, there's also a bunch of dangerous pathogens, in particular malaria and bacterial causes. And a challenge for African healthcare providers is that they often don't have, like the US, a comprehensive data set on what's causing these febrile illnesses. So there's lacking guidelines on evaluating and managing the treatment. And also, just as you can see from the World Bank, the morbidity and mortality due to febrile illnesses is pretty extensive, 99 per 1,000 versus 8 per 1,000 in the US. So, malaria remains an enormous burden in children in most of sub-Saharan Africa. African children account for more than 1 million worldwide deaths from malaria each year. But because of the danger of untreated malaria and the limited availability of diagnostic tests, the traditional approach was that children under 5 in Africa would be treated with anti-malarials without any diagnostic workup. In 2010, WHO changed their guidelines. There's a couple reasons why they changed the guidelines. One of them is that the more inexpensive older therapies such as chloroquine and sulfadoxine, pyrimethamine, have been replaced by more expensive therapies such as artemisinin-based combination therapies. Another reason is that diagnostics for malaria has improved. So the gold standard diagnostic test, GM-sustained smears, they are increasingly available for places such as Uganda where there's limited infrastructure. And finally, one of the reasons is just the proportion of fevers due to malaria has been decreasing. One systemic review showed that originally there were 44% of causes of malaria causes of fever were due to malaria from 1986 to 2000, but it has now decreased to 22%. So the literature, when I did a literature review on potential bugs or whether any kind of test like this has ever been done before in Africa, are pretty limited. I brainstormed a bunch of different bugs that I thought could be potential ones that I'll be able to find. They included viruses such as dengue fever, CMV, EBV. So some that are common also to the US, like Strep pneumo, Staph aureus, the Salmonella species, Asian flu. Klebsiella actually was pretty high in some of the papers I read. Then the Rickettsial species, and then TB and HIV. And then there are some special ones like Onyanang, which I was never taught in med school, and Chikungunya. It's interesting. And another thing we're also trying to find is previously unidentified pathogens. So later, the technique that I'm going to describe that we're going to use to detect these bugs is kind of a novel thing too that we're looking into. So the two aims that I have for my year is one, just to characterize the clinical presentation of Ugandan children who present to the hospital in Truro with fevers, and also to find associations between the clinical syndromes and also the identification of the unknown pathogens. So to go into my first aim a little more, I am going to be going to Truro Hospital in September. So there's this surveillance program that's ongoing with Dr. Rosenthal, the PI I'm working with. I'll go into a little bit more about the previous data, but we're going to use part of that data to look at kids who had already come into the hospital with fevers and just look into their histories and see what the clinical syndromes were. But we're also going to admit new patients. And we're going to get 390 subjects with negative malaria blood smears and 10 with no malaria as the positive controls. Or they're also obviously going to all have a documented axillary temperature greater than 38. And then we're going to characterize the children who are either 13 or younger and have been admitted for 4 months, greater than 4 months period. So this is part of the data that Dr. Rosenthal had from a previous surveillance test from 2010 to 2012. And it's kind of complicated, but just to summarize, for the 12,000 patients or so who were admitted for a temperature, it showed that there were roughly 63% had a positive malaria blood smear, and the rest, so even though there are a lot that were caused by malaria, there's also a lot that are not due to malaria. And my second aim is to identify the bugs. So,
Sure.
yeah,
Back
sure.
one slide.
Sure.
So I'm just looking at the deaths, and it looks like in some months, most of the deaths are not associated with malaria.
Yeah, there's actually another chart I didn't put up which had the deaths what the deaths were caused by. So there were a bunch like things in the US, like pneumonia, sepsis.
Were there ones that were unidentified?
Yeah, and there were ones that no one knows where they died. Sure.
I don't know anything about how they also so much, but you're only using people who are admitted, so you're not going to do like urgent care or emergency department presentations.
So I'm not sure how the hospital is set up there. I'm probably going to be looking at, I know in Kampala when I was there in the PEDS unit, it wasn't like the US where there's like an emergency room and then they like get sent to the floor. It was just one hospital and there was like a triage and it's whether if they're admitted for like a fever or malaria, they would put in a certain ward. So I'd probably be working in that versus emergency. Okay, so the second aim, yeah, we're using deep sequencing to characterize them. So I'm going to be helping with collecting blood samples, nasopharyngeal swabs, and stool specimens if they have diarrhea. Then we're going to freeze the samples and then ship them off to here to be, and then the blood samples are going to go through the process of just rigorous and getting the DNA libraries and trying to figure out what's the DNA sequencing and figuring out what bug it is. So, in conclusion, the significance, one is to find out what's causing these fevers so that we can provide just a direction in terms of diagnosing, treating, and preventing the fevers. And also, along the same lines, we could potentially treat fatal bacterial infections that could spread. References.
I'm curious whether the deep sequencing strategy that you've used before, has that been done in other places?
Yeah,
Is it
so,
successful?
sorry, so I didn't go into it, but this lab, the RISI lab, they did one in Nicaragua. I can't say it. That person, so when I heard it. They did it there, and they found a novel enterovirus. So it's pretty cool because unlike the traditional ways like serology and culturing, this allows for, which isn't as sensitive, this allows for detection of everything that has like at least 20%. If you can detect a 20% rate in the blood, it shows up. So it's pretty exciting.
So most of the genomes of the organisms that are coming have been sequenced already, so they'll be able to.
Yeah. So the one I had mentioned, Onyanyang, they had actually done like they got the blood from some random place in Africa, and they found that like in small amounts. So that's how I added that onto my list. I'm also doing a separate thing in case, because we're not sure how well this is going to work, the deep sequencing, because there could be a lot of contamination and we might just not come up with anything. So I'm also creating a PCR method, and I'm doing PCR on all the blood samples too, to detect like the 10 most common pathogens I think are going to be most likely.
Maybe this is sort of interesting, but is that kind of one of the risks of using deep sequencing, is that you'll pick up things that were just like low-level viremia and weren't actually was the major pathogen?
Right, yeah. And also even just common cause of contamination, like handling the blood or whatnot, it's really, it can be really sensitive.
So I was wondering if you could say a little bit more about your control group. If I remember correctly, it was on one of your slides. So it was 10 patients with known malaria. So is that, in terms of those patients serving as controls, I don't know a lot about the clinical spectrum of malaria, but is that enough to capture like the normal variation that you would see in, this history and symptoms?
So in terms of what strain they have of malaria, or?
Well, so you're characterizing what these 390 other subjects are going through, right? As an attempt to kind of correlate it with whatever pathogen you identify. But if you're going to compare what they're going through to the patients with known malaria, I'm just wondering if 10 patients is a small number, so say they all happen to have severe cases of malaria, is that going to influence, how you characterize the other pathogens?
So if all 10 of those have a severe form of malaria versus not as severe, is that going to? And
The question is
That
not
makes
about
sense.
the number,
Rephrase it.
like the
Like
quantity.
it's not enough.
Mainly because it's 390 patients versus 10. So can you, I guess, talk about how you arrived at this one?
They were actually just random number. I didn't even come up with them. I don't know. I'm not really sure. So I guess the numbers, I can't really give
I
it.
think the difference is probably between lab methods versus epi methods, and then from lab they're just looking at genetic material, but you're not thinking of it like an epi. Where 10 probably wouldn't be a right control group, but I think probably after you get all the results from the 390, there'll probably be subgroups, and then you probably derive, because you have the clinical impact. Joe, I don't know if you have any other thoughts, but using in lab methods, probably just 10.
That's my interpretation here too, is that this is just a way of showing that if you have 10 with malaria, that they're coming out with malaria on the deep sequencing, rather than
Oh, I see. So it's
rather
not
than having
fatal.
a sophisticated statistical comparison between the patients
Yeah.
with malaria and their clinical symptoms versus the non-malaria and their clinical symptoms. Because clearly this is biased in the sense that I imagine just a small fraction of children who are febrile with malaria get hospitalized. So this is a subset of what I think some of the others are referring to, the most severe cases. So, where I think you'll probably get a lot of great information is in the non-malarial cases. They'll say that this non-malarial case associated with chikungunya has these findings compared with non-malarial cases with dengue, and those findings. Probably 20 or 30 or 40 or 50 of each of those, and that's where you'll have probably more power to do comparisons.
I just have one question. So I think the way they admit is kind of the same around Africa, which is triage and then to the ward. And one of the things that occurs a lot, at least in my observations involved, is they come in with, like, let's say diarrhea, some typhoid looking thing, and then they become febrile on day 3 while they're in the hospital. So, and spike for a while and whatever. And so are those children included in the study since you're finding them in the ward? Because they actually came in with something else completely and instead spiking in the ward. Should you be swabbing around the ward and finding that is the ward the source? You know, since you're deep sequencing a bunch of bugs and you're trying to figure out which one is causing a fever.
We're only including children who are admitted with fevers, since, I mean, I'm sure a bunch of children come in and we're able to limit because we only need 400 patients. So if we just get the admitted diagnosis, it simplifies it.
I'm just curious whether you thought about including non-febrile controls to see if there are any organisms which have, carriage, which are asymptomatic, which then might make you conclude that that's the cause of the febrile illness.
Yeah, I didn't think of including non-febrile. I'll take that into.
Just in case there is some bug there that a lot of people have.
Right, that's
Yeah.
not causing
Right.
fever, but is
Yeah, my comment was kind of similar to that. 'Cause I actually was in Eurese's lab for grad school. So I was around when Nick everything was going on, and his focus is discovering new viruses and not so much with clinical correlation
Right.
necessarily. So I'm wondering if you were planning to do some follow-up to see if this is actually just something that just is along for the ride, or is actually
Right.
driving.
And that's also part of the reason I'm doing the backup PCR technique, because that way, I'll be more specifically looking for certain bugs and seeing what clinical symptoms.
Now, will you be doing real-time PCR too to get evidence of quantity? Like
Quantity,
Musa.
I was wondering if you could perhaps speak to some of the clinical resources available to actually treating these diseases. So, it's one thing to actually diagnose, some sort of virus, but what sort of research do they have available for treatment of antibiotics if they do discover, organism strain of strep pneumo versus something like that?
From my personal experience when I was in Uganda last year, they have most of the antibiotics to treat the general bacterial diseases. I would say I'm not sure about like the more rare things, whether they have resources, but for the most part.
Because, I was wondering for, a lot of the more general things, you could always do something like a blood culture or, like a culture of your throat, which, I'm sure they do have there, but some of the more things like that one virus I've never heard of. I'm wondering if there's a treatment for that or not. It's going to make a big difference when you diagnose things.
In general, there's probably no treatment available for any of the causes of death unrelated to things. You can treat malaria, though not all. You can treat most of the bacterial ones, but if there's a fancy new virus out there, there's not going to be anything anybody can do yet.
Even with, I was reading about the unknowns and like what the treatment would be. Things for that, it's usually just supportive care. There's no actual treatment.
Any other questions for Jen? So I have a question, a very important one.
Okay.
Since you come from Mayo, were you guys talking at all about UCSF students in Rochester after the last TL1 meeting.
I was the person who was talking about it. I didn't hear anyone talking about it.
The last time we had our TL1 meeting, last two meetings were in Rochester, hosted by Mayo, and your predecessors made a name for themselves.
What happened to what happens in Mayo?
Thank you very much.
So you guys should take some of this. I'll use some of this for free, you know, why don't you take it?